Right, okay. So, good evening for everyone. Students, today we are going to discuss unit test paper. So, there are 50 MCQs to discuss. Let's see what are the mistakes that we have done in the questions, okay? Right. And if you have any doubts, please put your doubts in the chat box, okay? Right. So, question number 1. Select the correct statement from the following. Gamma rays are negatively charged. Is that correct? Wrong. Beta rays are positively charged. Students, beta rays are negatively charged. Alpha rays have positive charge. Of beta rays, alpha rays have opposite charge of beta rays, and its charge is twice the charge of beta rays. You know that, students, beta rays means actually electrons. E minus 1 0. So we know that alpha rays means helium nucleus, helium 2 2 plus. Okay. So when you consider the charge value, right, charge value of electron, so here we can say that the charge value is 1.602 10 to the power minus 19 coulomb. And we know that in helium nucleus there are two positive charges, right? So therefore, one proton's charge is 1.602 10 to the power minus 19 coulomb. So therefore, the helium nucleus or else alpha rays are having charge twice the charge of beta rays. So therefore, that statement is correct. Okay. Third statement is correct. First one wrong, second one wrong, but the third statement is correct. Number 4. In a magnetic field, gamma rays are deflected perpendicular to the magnetic field. Wrong. Gamma rays are neutral. Since gamma rays are neutral, they can't go for a particular direction. They won't deflect. They won't change their path. They are going directly in the path they came, right? So therefore, that is wrong. Result of the Rutherford's gold foil experiment could also be obtained by bombarding gamma rays on a thin gold foil. Is that correct? The Rutherford experiment we conducted by using alpha particles. And I told you that why we are using alpha particles? In order to find out the nucleus. Nucleus is positively charged. Alpha rays are also positively charged. So because of those positive repulsions only, so those kind of observations that we got, that's how we found the nucleus. So therefore, no point of using gamma rays. Okay. So therefore, the fifth statement is also wrong. Question number 1, answer is third one. Raise your hand those who got the answer as third one for question number 1. Right. Question number 2. The correct statement regarding the substances N3 minus, nitride, oxide O2 minus, fluoride is, right? So they have given nitride, oxide O2 minus, and fluoride F minus. Look at this, Anil. N3 minus, O2 minus, F minus. So what is the specialty of these three species? What is the specialty of these three anions? N3 minus, O2 minus, F minus. What is the specialty of these? Put your answers in the chat box. Yes. Remember, students, these are isoelectron. We can consider these are isoelectronic. Isoelectronic means they have the same number of electrons. Atomic number for the nitrogen is 7, oxygen is 8, chlorine is 9. So therefore, the number of electrons here in everything is 10, right? So here we can see that there are 10 electrons. So let's see what are the statements they have given. They all have neons configuration 3s2, 3p6. 10 electrons are there, then the configuration should be 1s2, 2s2, 2p6. Students, they should have the neons configuration. So they have given neons configuration 3s2, 3p6. That means argon's configuration, right? So this is the electronic configuration for the all three anions, neons configuration. So therefore the first statement is wrong. Question number 2, first statement is wrong. What about the second one? Their nuclear charge ascends in the order F minus O2 minus N3 minus. Nuclear charge. Nuclear charge is determined by the number of protons, 7, 8, 9. So they are asking the ascending order. So therefore, students, the nuclear charge is ascending for this direction. So this is the nuclear charge. Okay. So therefore, the given variation is wrong. Second one is wrong. Third one, above species are not isoelectronic. They are isoelectronic. Okay. Third one is wrong. Fourth one, the ionic radii ascend in the order F minus O2 minus N3 minus. There are 10 electrons, number of protons 7, 8, 9, right? So when you compare the electron count and the proton count, here 10, 7, and here 10, 8, and here 10, 9, right? So the electrons are same. But when we consider the proton count is different. That means the nuclear charge is changing. When the nuclear charge increases, what will happen to the radius? Radius is decreasing. Then the highest radius belong to N3 minus. Second one should be O2 minus. Third one is F3 minus. Understood? So therefore, the ascending order of the radii should be F minus, O2 minus, N3 minus. So the given variation is correct. Yes, fourth one is correct. Number 5, they have equal radii. No, that's wrong. They have different radius. So question number 2, answer should be fourth one. Question number 2, answer should be fourth one. Raise your hand those who got the answer correctly. Raise your hand those who got the answer correctly. Question number 3, related to the electronic configuration. Let's see. What is the element with the highest number of unpaired electrons in the outermost d sub-energy level? Copper, zinc, iron, manganese, cobalt. Right. Now let me write down. Let me write down here electronic configuration of these chemical species, elements. Copper. Copper electronic configuration. So let me write down the valence configuration only, outermost d sub energy level n. So copper is 3d10 4s1. Okay. Then zinc 3d10 4s2. Then what about iron? Iron is 26 3d6 4s2. Manganese 3d5 4s2. Cobalt 3d7 4s2. Students, they are asking highest number of unpaired electrons. So here in the 3d sub-energy level, that is completely filled, no sub-energy level. But in the sub-energy level, we have one unpaired electron. Zinc, everything is completed, perfectly completed. So therefore, no unpaired electrons. What about iron? In the d sub-energy level, we know that there are 5 d orbitals. 1, 2, 3, 4, 5, and the 6th. Then how many unpaired electrons are there? So they're asking number of unpaired electrons. Number of unpaired electrons, 1 here, 0 here. Here you can see 4 unpaired electrons. Okay. Then what about manganese? In the d sub-energy level, configuration is incomplete. 3d5, 1, 2, 3, 4, 5. So S2 is complete. Cobalt 3d7. 1, 2, 3, 4, 5, 6, 7. There are 3 unpaired electrons. So therefore, this is the maximum number of unpaired electrons. And then the answer should be manganese. So question number 3, answer should be manganese. Fourth one. Raise your hand those who got the answer as fourth one. It's very simple thing, huh? Electronic configuration. Let's move to the question number 4. That is hydrogen emission spectrum. Quickly. Now let's move to the question number 4. Consider the following statements regarding the hydrogen emission spectrum in the given diagram. Okay, let's see what is the given diagram here. They have given 5 energy levels. One, two, three, four, 5. So they have given 2 lines like this. Capital A. And they have given another line here. This is capital B. Right. They have given 3 statements A, B, C. Let's see. Frequency of line A is equal to the frequency of line B. Students, that is wrong. Okay. So now tell me this A line, capital A, belongs to which series and capital B belongs to which series? Capital A transition from 2 to 1. Capital B transition from 5 to 2. Right? Then this line belongs to Lyman series. And this line belongs to Balmer series. No? So let's, shall we complete the other lines also? Shall we complete the other lines? In the Lyman series, what are the possibilities? We can take 5 to 1 electron transition. Then we have 4 to 1 electron transition. Then we have 3 to 1 electron transition. Then 4, 2 to 1. In the Balmer series, we can have 4 to 2 possibility. And here 3 to 2 possibility. So this is the highest frequency, highest energy. So we can say that for this direction, from left to right, energy and the frequency decreases. Decreases. Wavelength lambda increases for that direction. Decrease and wavelength decreases. Okay, because this is the highest frequency. Look at the gap, right? The largest energy. So the first statement is wrong. Simple A statement is wrong. Simple B, the locations of the lines A and B are consecutive in the spectrum. Yes, that means students, after this line, now this is the last line that we can obtain from the Lyman series when you consider this direction. So after this one, the next one should be Balmer series, this one, in this diagram. Because in this diagram, they have given only 5 transitions, 5 energy levels. Then these are the possible transitions. 5 to 1, 4 to 1, 3 to 1, 2 to 1. Lyman is over. Then we can go for the 5 to 2, 4 to 2, 3 to 2. Then after that, we have a Paschen series 5 to 3, 4 to 3. Bracket 5 to 4. So therefore, these are consecutive, one after the other. That statement is correct. Right? A and B represent the electron transitions of 2 lines in the 2 consecutive series. Are they 2 consecutive series? Yes. This is Lyman series and this is Balmer series. right? Even the series also consecutive. C also correct. Then the correct statement is only AB, only BC. BC statements are correct. Question number 4, answer is second. Raise your hand those who got the answer. Raise your hand those who got the answer correctly. Right. Good. If you have any doubts, put your doubts in the chat box, okay? Question number 5. Which of the following correctly matches the discovery and the relevant scientist? Number 1, they have given charge of an electron found by James Chadwick. Charge of an electron, they have given James Chadwick. Right? Is that correct? Wrong. Charge of an electron was found by Robert Millikan. Number 2, mass of an electron. Mass of an electron is, they have given Neil Bohr. No, wrong. Okay. After finding the charge and the E over M ratio, the mass can be found, that Honor going for the J.J. Thomson. That's wrong. Third one, E over M ratio, value and value of an electron. So that is J.J. Thomson. Yes, that's correct. J.J. Thomson, that's correct. Third one is the answer. Let's go for the other one, neutron. Neutron was discovered by R.A. Millikan. That means they are telling Robert Millikan. Wrong. That's wrong. Neutron was discovered by James Chadwick. That's wrong. Isotopes. No. Isotopes wasn't found by Goldstein. Goldstein found positive rays. Okay. So therefore, that's also wrong. Okay. We are not discussing the scientist name who found the isotopes. But when you search this one in Google or somewhere, you can find out who are the scientists involved in the finding isotopes. Okay. But that is not relevant to us. Anyhow, this is wrong. So the correct answer should be third one. Question number 5, answer is third one. Raise your hand those who got the answer for the fifth one. Very simple, huh? Right. Now let's move to the question number 6. When moving across a period that doesn't belong to the D block in the periodic table, the element named capital A was found to have the highest fourth ionization energy. The group that capital A belongs to. Students, remember, I taught you, when we are discussing about the ionization energy and the ionization energy graph, I gave you a table. Can you remember that table? So in that table, the highest first ionization energy belongs to which group, right? So let's analyze the group. In which group? First ionization energy highest in which group? Group number? Quickly, answer. 18. Lower in group number 1. Second ionization energy highest in group number 1, lowest in group number 2. Third ionization energy highest in group number 2, lowest in group number 3. Fourth ionization energy highest in group number 13, lowest in group number 14. Fifth ionization energy highest in group number 14, lowest in. So likewise, there is a pattern also. I taught you this pattern. Right? If you can remember this table, going for the answer is very simple. Okay. So we have proven this one by drawing the second ionization energy graph and the third ionization energy graph. Then tell me, students, they have given this element belongs to the this element has the highest fourth ionization energy. Highest fourth ionization energy belongs to the group number 13 elements, right? Boron, aluminium, gallium, indium, thallium like elements are having highest fourth ionization energy. So therefore, question number 6 answer should be third one. Question number 6 answer should be third one. So these are completely theories that you learn, okay? We have discussed these theories in the class. Frederick Soddy found isotope. Oh, this is the guy. Right, okay, now let's move to the question number 7. The pair of periodic properties that shows gradual increase and gradual decrease respectively across a given period in the periodic table. Number 1, atomic radius and the first ionization energy across a given period. So we have to find out period wise how these properties are changing, right? Look at the first one they have given. They have given atomic radius and the first ionization energy, right? Atomic radius, first ionization energy. What else? What are the other factors they have given in other answers? They have given electronegativity, electronegativity, uh, and the second ionization energy. Okay, students, when we consider Right, okay. When you consider these four properties, how they changing along a period, students, we know that when we consider atomic radius decreases along a period from left to right. So therefore, they have given a gradual increase or gradual decrease. Atomic radius is gradually decreasing, right? So that is gradual decrease. Okay. What about the first ionization energy? So the first ionization energy, we know that we have zigzag variation like this, right? It's not a gradual increase or gradual decrease. So therefore, this is zigzag variation. Zigzag variation. Neither increase nor decrease. Okay. Even the second ionization energy, zigzag variation. What about the electronegativity? Electronegativity is increasing along a period. So when you go for the fluorine, oxygen, nitrogen-like elements, so they are actually at the right side of the periodic table. So therefore, electronegativity is gradually increasing along a period. Gradual increase. So they are asking here, gradual increase and a gradual decrease. So therefore, answer should be electronegativity and the atomic radius. That order is important. So therefore, question number 7, answer is second one. Question number 7, answer is second one. Raise your hand those who got the answer as the second one. Good. Right. Question number 8, again, that is related to the hydrogen emission spectrum. Let's see. Assume that an electron of an hydrogen atom is excited to the fourth energy level in an experiment on the emission spectrum of hydrogen, right? Which of the following is correct regarding electron transition if the electron first moves from the fourth to the second energy level and then go to the ground state? Okay, so that means, students, electron is actually going for the move from the fourth principal energy level to the second principal energy level, then from second principal energy level to ground state. Ground state means the first principal energy level. Understood? So therefore, when we consider the diagram, so let me draw the diagram. In this way. So they are telling that electron is actually transferring from, move from the fourth to the second energy level. Fourth to the second energy level, and then from second energy level to first principal energy level. Right? So these are the two electron transitions that they have given. Number 1, H alpha and H beta lines are obtained. Students, we know that if that electron transition taking place up to the second principal energy level, that is definitely in the Balmer series. In the Balmer series, we know that H alpha means n equal 3 to n equal 2. So this is H alpha. Then this is H beta, the next one. H alpha is red color and this is green color, H beta. So the given electron transition is 4 to 2. So it is not red color, wrong. And this is actually belongs to the Lyman series. So therefore it's not H beta, right? So therefore the first statement is wrong. First statement is wrong. Lines in the Balmer series are not obtained. So we have one line. 4 to 2 means Balmer series line. Number 3, H beta line. Yes, 4 to 2, H beta line. And a line from Lyman series are obtained. Yes. So 2 to 1, that means electron transition to the first principal energy level, Lyman series. So therefore, that is the answer. Lines in the Lyman series are not obtained. Now we have a line. The two lines that are obtained due to the electron transitions are the lines pertaining the Prakat series. No way, right? So therefore, here answer should be third one. Question number 8, answer should be third. Okay. Raise your hand those who got the answer correctly. Let me see. No, IFASA, we can't take that one as fourth one because first ionization energy is not gradually increasing. Understood? That is a zigzag variation. We can't take like that. Right? Question number 9. What is the number of orbitals containing unpaired electrons present in the last sub-energy level of an element whose valence electronic configuration is 4s2 4p4? Very easy. Look at this one. 4s2 4p4. Right? So can you hear me now? Can you hear me? Right. So therefore, students, when you look at this configuration 4s2 4p4, remember in 4s2 4p4, you can see that in the p sub energy level there are three p orbitals. So one orbital is containing paired electron and the other two orbitals are containing unpaired electrons. So therefore, they are asking how many orbitals are there with unpaired electrons. So two orbitals are there. Question number 8. Question number 9. Answer should be number 1. That's very easy. Raise your hand those who got the answer. So you can't make mistakes in these kind of questions, understood? No, 3D10 is missing means 3D10 come before 4s2 when we write down the electronic configuration. Now, so when we consider the element here, so the element that they're talking about here is, what is it? Zinc, gallium, germanium, no? Carbon, silicon, germanium. So therefore, 4s2 4p4. So then nitrogen, phosphorus, arsenic, here oxygen, sulfur, selenium. Selenium is 34. So therefore 1s2, 2s2, 2p6, 3s2, 3p4, 3p6, 3d10, 4s2, 4p4. Okay. So 10, 30, 30, 34. So therefore, this is about selenium, right? So in the selenium, so this is the valence shell, no? Fourth principal energy level. So 3D we have to forget in the electronic configuration. Understood? Right. Next one. Right. Okay. Now, so so they have given here cobalt's electron filling order, right? Not the configuration. So students, first of all, we have to write down the electronic configuration of cobalt, right? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. Okay. So the reason I gave you this question is sometimes you make a mistake here. Without writing the electronic configuration, you just remove the 2 electrons from here and consider that 3d5. Is that correct? That's wrong. Because this is electron filling order, right? We have to consider this is electron filling order. They have clearly mentioned that. Electron filling order. Then what is the electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. Right? So when it is producing cobalt 2 plus cation, then the configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d7. So these 2 electrons are removed. Then you can see that what is the valence shell electronic configuration of cobalt 2 plus 3d7. Now 4s0 in this electrons fourth principal energy level, s orbital is completely empty. So therefore 3d7 4s0. Question number 10 answer should be number 5. Question number 10 answer should be number 5. Okay. Raise your hand those who got the answers number 5 correctly. Good. Yes. What are the doubts you have? No, third one and the fifth one is not same. Third one and the fifth one is not same because in the third one they have given 4s0 and pd7. They are asking valence shell electronic configuration of cobalt 2 plus, right? Then we have to consider that is 4s0 should come at last. Understood? So we can't put that one there, right? Third one and fifth one are not same. So here the order matters. Okay. Now let's move to the question number 11. Which of the following correctly depicts the variation of the first ionization energy of sodium, magnesium, aluminum, and silicon? Right. So can you remember the first ionization energy graph? So let's quickly draw that one. Let's revise the first ionization energy graph. Now you should be able to draw that graph in your mind. Okay. That's very easy. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, fluorine, argon. In my graph that I have drawn, here second period and the third period are independent. Okay. Okay. So when you consider the now sodium, magnesium, aluminum, silicon, so these are third period elements. So these are the set of elements: sodium, magnesium, aluminum, silicon. So when you consider that one in order, aluminum, silicon, sodium has the least ionization energy than magnesium. When you consider magnesium and aluminum, magnesium is greater. Aluminum and silicon, silicon is greater. So where you can see this kind of a variation, you have to see it clearly. First one. Question number 11, answer is first one. Raise your hand those who got the answer. Right. What is the basis of the modern periodic table? Very easy. Electronic configuration and atomic number. Question number 12, answer is third one. So that is direct theory. Normally in our A-level exam paper, they won't ask direct theories. Right? Some of you are telling that paper is hard to. See? Who said that paper is hard? Direct theories are there. Who will give this kind of easy paper? You can't score 40 MCQs out of 50, 80%. Okay? You're very unlucky. So you are demotivating us. No, it's not like that. I just kidding. Okay. I told you no yesterday. So this is a easy paper. Okay. Marks doesn't matter. Question number 13. The wavelength of a yellow light formed in a certain spectrum is 569 nanometers. The energy of 1 mole of photon of this wave is. Right. So shall we do the calculation? So the wavelength is given 569 nanometers. They're asking the energy of a photon mole. Students, how we can find out the energy of a photon? We can find out the energy of a photon using E equal hc over lambda equation. So here E representing energy of a photon. In order to find out the energy of a photon mole, then you have to multiply this value by Avogadro number. So Planck's constant 6.626 10 to the power minus 34 joules seconds. Velocity of light 3 into 10 to the power 8 meters per second. Avogadro number 6.022 10 to the power 23 per moles. Divided by, what is the wavelength value they have given? 569 nanometers. Nano means 10 to the power minus 9. Therefore, 5.69 into 10 to the power minus 7 meters. That is the wavelength. Then 5.69 into 10 to the power minus 7 meters. Meters will cancel out. Second per second will cancel. Then the remaining unit is joules per mole. Can you remember I told you Avogadro number and the Planck's constant multiplication is equal to 39.9. Use it. 3 multiplied by 39.9 divided by 5.69. What about the 10 to the power values? 10 to the power minus 7 cancel off. Here 10 to the power minus 27. Then here 10 to the power minus 27. 10 to the power plus 23. What is it? Minus 4. And minus 4 plus 8. 10 to the power 4. Joules per mole. Students, they have given the answer in kilojoules per mole. Right? So kilo means what? Kilo means 10 to the power 3. Then I can take 10 to the power 3 out of this. 3 multiplied by 39.9 multiplied by 10. 10 to the power 3 joules per mole divided by 5.69. 10 to the power 3 joules means what? Kilojoules. Okay. Then 3 multiplied by 399 divided by 5.69. Kilojoules per mole. Okay. Check whether this value is divisible by 3. Sometimes that value can be divided by 3. 5, 6, 11, 11, 9, 20. No, it's not divisible. No, not divisible. Then use the logarithm. Use the log table. What is the log value for 3? 4771. 0 point. Log value for 399. 39.9 for 6010. 187. 3.0781. Log value for 56.9. What is it? 56.9. 7551. 0, 3. 3230. Antilog of 3230. 3230. 2104. So the answer is 210.4 kilojoules per mole is the energy of moles of water. They have given the exact answer in the answer number 4. Question number 13, answer is number. Raise your hand those who did the calculation honestly in the examination time without using the calculator, by using the logarithm. Okay. I hope that you didn't use the logarithms. Okay. Complete the calculation. Quickly complete the calculation. Question number 14. Possible set of quantum numbers for unpaired electron in ground state of copper atom could be. Right. Copper atom has one unpaired electron in the electronic configuration. Can I remember? Copper is 3d10 4s1. So therefore, in the valence shell, we have one unpaired electron. So for this electron, we can write down two set of quantum numbers. Two possibilities are there. 400 plus half if the electron is rotating to clockwise direction, or else 400 minus half. But we don't know exactly which one is the correct one. So therefore, the correct answer that we can accept is first one is wrong, 3. Second one, 4, 1, they have given 4p sub-energy level, wrong, because this is 4s sub-energy level. Third one is also wrong, 4p. Fourth one is wrong, that is 3d. Fifth one is correct, 400 plus half. So that is a possible set of quantum number that we can take. So therefore, question number 14, answer is number 5. Raise your hand those who got the answer. Quantum numbers. No. No more. In our chemistry paper, we don't have any practical questions. Okay. But there is a practical book. So you can buy that one. Do you know that practical book? So this is the chemistry practical handbook that you have. So this one, issued by government. So if you want, you can buy this one. Understood? And you can refer the practicals. So all the practicals that we are discussing in the theories also. Specifically, we have to discuss some practicals, especially in kinetics. Unit number 11, there are some practicals. And unit number 4, there is a practical. And enthalpy practicals are there in unit number 5. In the examination, so far they have asked only unit number 5 and kinetics practicals only. Okay. So compulsory practicals will be discussed. Okay. In the class. Right. Now let's move to the question number 15. A sodium vapor lamp emits yellow color in the visible light. Wavelength is 582 nanometers. The lamp generates energy of 8 joules per second. Number of photons generated by that lamp within 66.2 seconds is, right? Okay. I think we have discussed this question in the memory booster paper also, right? As I can remember. Yeah, if you can buy the resource book, that's better. Okay. If you are doing practicals at school, then that's better you buy that one. If you are doing practicals. Otherwise, with the practical handbook, what you're going to do? You can just look at that one, go through that one, what other things are there like that. The practical handbook is needed when you are doing practicals. Okay. Right. Now look at this, Anilu. So here they have given a sodium vapor lamp emits yellow color in the visible light. Wavelength is 582 nanometers. That lamp generates energy of 8 joules per second. Number of photons generated by that lamp within 66.26 seconds. Right. Look at this, Anilu. So they have given that energy per second, 8 joules. Then when this lamp is actually lit for 66.26 seconds, then this is the energy emitted by that lamp, right? Now we have to find out how much of photons used to generate this much of energy. Then this is the energy, right? Then you can find out here the total energy is equal to number of photons multiplied by energy of a photon. Energy of a photon is Hc over lambda. So we have to find out n value because H and C values are known. Planck's constant 6.626, 10 to the power minus 34 joule seconds, velocity of light 3 into 10 to the power 8 meters per second, lambda wavelength 582, that means 5.82 10 to the power minus 7 meters, right? Second per second will cancel off here. So here we have 8 into 6626 joules. Joules will cancel off. Second per second will cancel off here. M will cancel off. Since we are finding number of photons, that is units. 8 multiplied by 66.26 multiplied by 5.82 10 to the power minus 7 divided by 6.626 multiplied by 10 to the power minus 34, 3 into 10 to the power 8. Look at this. 66.26, 6.626. When you multiply this one by 10, you will get this one. So therefore 10. Cancelling off. Is this divisible by 3? 13, 15, 6, yes, divisible. 1 here. 28 means 9, 27, 12 means 1.94. Then n equals to 1.94 multiplied by 8. What is the answer? 32, 3 here. 72, 75, 7 here. 8, 50. Then 15.52, 10 to the power values, plus 10 to the power minus 7 here, cancel off, 10 to the power minus 27. 10 to the power minus 27, 10 to the power 8, what is it? 10 to the power minus 90, right? Minus 19 is going for the numerator as plus 90. And already 10 is also there. Then what is the answer? 15.52 into 10 to the power 20. In the correct scientific notation, 1.552 10 to the power 21 photons. In order to emit this much of energy per for 66.26 seconds, this is the number of photons that this energy should be supplied. Okay, 1.552 10 to the power 21. Then what is the answer? Question number 15, what is the answer? Second one. Raise your hand those who got the answer correctly by doing a calculation. Remember students, both the calculations that we did in 13 and 15 are not that much difficult, okay? You can't say that we use very difficult calculations. We did not difficult calculations. Those are very simple calculations. Even here, I didn't use the logarithms. Okay. Continuously do the calculations, Takira. Don't worry. Okay. At the beginning, we also like that only. Don't worry. Okay. When you work continuously at a point and a particular point, it will work. You continuously do will. So can I know who got the highest marks in? Now, few students asked me, yes, who is the highest in the unit test. I think I can't exactly remember who is it, but I saw the marking sheet. A senior only checked your marks, and I told that admin Amasha to send your marks. In physical classes, the maximum I think 80. Umar Pamudi, what are your marks? In Kolonna class, Pamudi is the highest, I think. In Vellavatta class, Umar is the highest. 80, 86. 86. Okay. In online class, I saw that 92 was also there. I can't remember who's that now. Can anyone tell me who got 92 marks? I think she is not here. Gloria Paris, 92%. Senuki, 88%. Joella Lakisha, 88%. Omaya, 88%. Joella, 82. Yes, those are the maximum. So I think highest is Gloria. Gloria is the highest. I think Gloria is not in the session. Yes, she is not there. Okay, why you are asking the highest marks? After knowing that, what is the use of it for you? Right. Question number 16. Remember, always competition is with you, okay? Not with the others. Always your maximum, with your maximum. Question number 16. The response which correctly represent the order of decreasing energy of following quantum number set is. So they have given n equal 4, 0, 0 plus half, 3, 1, 1 minus half, 3, 2, 0 plus half, 3, 0, 0 minus half. Okay. Students, tell me what are the sub-energy levels here? 400 plus half means fourth principal energy level, S sub energy level. And this is third principal energy level, P sub energy level, 3, 1. So this is 3D sub energy level, and this is 3S. Okay. So these are the quantum number sets that they have given. So now they're asking the response which correctly represent the order of decreasing energy of the following quantum numbers, right? Then tell me which one has the highest energy among these four. 3s, 3d, 4p, 4s. Which one has the highest energy? Can you remember the Aufbau principle? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 6s, 6. In this way. So this is 4s, right? Then we have 3p. Then we have 3d and 3s. So remember, the highest energy belongs to 3d. See, 1s, 2s, 2p, 3s, 3p. After that, 4s. Then only 3d. Then 3d has the highest energy. C. 3d has the highest energy. First of all, let me write down the energy order 3d. Then we have 4s. After that, at last we have 3s. Then 3d means C. 4s means A. 3p means B. 3s means D. CABD. Answer is third one. Question number 16, answer is third one. Raise your hand those who got the answer.
3,000
Please mute your microphones.
அவங்க நினைச்சிருந்தா 20,000 எடுத்திருக்கலாம்.
Right, okay, now let's move to the next question. Question number 17. A, B, C are three elements with only one unpaired electron, which belong to fourth period. Okay. Unpaired electron in capital A and capital C can have same principal quantum number, azimuthal quantum number, magnetic quantum number, and same or opposing MS values. That means spin quantum number values. Unpaired electron of B can have 10 set of quantum numbers. 10 set of quantum numbers, right? Elements A, B, C can be respectively. Okay. Right. So that is also from quantum numbers and the electronic configuration, both. Let's see. So look at this one. A, B, C are three elements with only one unpaired electron which belongs to the fourth pair. Okay. So first of all, check all the elements. Are they in the fourth period? Potassium, scandium, copper, gallium. Yes, all of them are in the fourth period. Unpaired electrons in A and C can have same N, L, Ml values and same or opposite Ms values. Principal quantum number is same in A and C. Principal quantum number is same. Then L value, angular momentum quantum number, same, and the magnetic quantum number is also same. Okay, unpaired electron in A and C can have the same values. Same value of NL, ML values. Or opposite, same or opposite MS values. Unpaired electrons of B can have 10 set of quantum numbers. Okay. In order to have the unpaired electron of B can have 10 set of quantum numbers. Right. Okay, look at this one. Students, in order to have 10 set of quantum numbers for one particular electron, that electron should lie in which sub-energy level? SO, P, or D? Yes, that is the point. Right, that electron should lie in the D sub-energy. Then they have given two D electrons, scandium and copper. Potassium belongs to S block, gallium belongs to P block. Scandium and copper, they both belongs to D block. But look at the scandium configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 3d1. What about copper? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, and 4s1. The unpaired electron in the copper is not belong to the D sub-energy level. So therefore, in copper, this electron cannot have 10 possible set of quantum numbers. Can you understand? Only 2 set of quantum numbers can be there for this unpaired electron in copper. Then for the scandium only, 3d1. Students, 3d1 means there are 5 orbitals. We don't know this electron is located in which orbital for which direction. Right? So therefore, there are 10 possible set of quantum numbers. So therefore, the capital B element should be definitely scandium. Knowing this is enough to go for the answer. Why? You can see that all the 5 answers, B is scandium, given only the first answer. Right? In the second answer, the middle one, capital B, is gallium. Third one, it is copper. Fourth one also copper. Fifth one also copper. So I told you we can't take. Then easily you can go for the answer by just considering that last statement. Raise your hand those who got the answer for this question in the examination. Right, very good. So therefore, so what about then potassium and copper? Are they satisfying the given conditions? Now they have given that unpaired electrons in A and C have same NL, ML values. Now this is the unpaired electron in copper. No? Now they have given potassium also. Capital A should be potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Correct, no? So this is also 4s1 electron. Same principal quantum number, same angular momentum quantum number, same principal energy level, same sub-energy level, same magnetic quantum number, because that is in the sub-energy level. Only the rotation can be changed, or sometimes that also can be equal. So they have given that. Same or opposing MS. Then the answer should be A, potassium, B, scandium, C, copper. Question number 17, answer is first one. That's a very, very good question. That's a very good question. Very interesting question. Right, okay. Now let's move to the question number 18. Consider the following nuclear reaction. X can be very easy. Nitrogen 714 isotope reacting with alpha particles 2,4, producing X and neutron 0, 1. So in nuclear reactions, what did I tell you? How to balance these reactions? Normally we know that when you're balancing the reactions, summation of these atomic numbers, these things, should equal to the summation of atomic numbers in the right side. 2 and 7, 9. So therefore here 0, we have to put 9. Here 14 and 4, 18. So here 1, then this one should be 17. So 917, what is this? Fluorine. Isotope of fluorine. Fluorine 917. Question number 18. Answer is 12. That's very easy. Question number 19. 18 answers. Yes, what are the doubts you have? It's okay, completely all right. Okay. Question number 19. So that's also a calculation using isotopes. So let's do that one. Look at this one. So they have given two isotopes, bromine 79, bromine 81. So the exact mass value is given 78.918. So the relative abundance is given 50.54, right? So this is the mass of bromine, and this is the relative abundance. So here they haven't given mass. Relative abundance is also not given. They are asking what is the mass of bromine 81 isotope. Okay, so they have given average relative atomic mass is given. Average relative atomic mass. I'll start from there. Average relative atomic mass, this is equal to, so what is the mass of bromine atom? So we can consider, students, now we are doing the calculation using logarithms. In logarithms, we should have only 4 values. So therefore, let me take the approximate value 78.92. Okay, multiplied by relative abundance value is 50.54 plus X value. That means this is the mass of bromine 81 isotope. So that's what we have to find out. What is the relative abundance value here? So if this is 50.54, 100 minus this value is the relative abundance of bromine 81 isotope. Here 6, 4, 9, 4 in this way. So therefore 49.46 divided by 100 is giving the answer. So average relative atomic mass they have given 79.91. Okay, 78.92, 50.54, 49.46. Multiplied by 100. 7,991. Okay, let me find out the value for this one using the logarithms. Take the log table. 78.92. Don't be lazy. Take the log table and do the calculations with me. 78.92. So that is 89.72. 1 point. So what is the log value for 50.54? 50.54. 70.36. 0. 1 point. 8, 10 in this one. 6,008. 39.8. 8. 39.88. Then subtract these two values. X into 49.46. 7,991. 3,988. Difference is 3 here, 0, 0, 4. 4,003. X equal 4,003 divided by 49.46. 4,003 log value 3.4003. 6024. What is the log value for 4946? 6942. 6942. 1 point. 2, 8. 9082 antilog. It can't be, right? Did I make any mistake here? Right, okay. Now you can hear me, right? So students, 80.95. I told you that I'm going to take this 78.918 as 78.92. That means I have increased the value. So therefore, we are getting a small difference in the answer. In the marking scheme, in the answer sheet, they have given third one is the answer. That means 80.92. Approximately, we can take that one as the answer. Right now, we got 80.95 here. Okay, because I rounded off this one to 78.92. Then I should get a value which is greater than 80.92. Then I got 80.95. Then from that approximation, we can go for the answer. Question number 819, answer is number 3. Understood? Okay. Raise your hand those who did the calculation honestly in the examination time and got the answer correctly. Right, good. There are some students. If you can do this kind of a calculation and go for the answer like this, then you are in a good level of calculations. Right, quickly complete this one. Right, okay. Shall we move to the next calculation? Next question. Question number 20. Effective nuclear charge fell by the valence electron of sodium. Look at this one. Students, what is effective nuclear charge? ZFF is equal to nuclear charge minus shielding effect. Can you remember that? So effective nuclear charge is used to compare the atomic radius. I told you that atomic radius is inversely proportional to the effective nuclear charge. When the effective nuclear charge increases, atomic radius is decreasing. So using this equation, we can calculate the ZFF value for the sodium. So the nuclear charge for the sodium, what is the value? 11. And what is the shielding effect? Shielding effect means 10. So therefore 11 minus 10, what is the answer? Plus 1. Okay. So therefore, effective nuclear charge fell by valence electron of sodium equals to plus 1. Question number 20, answer should be second one. Raise your hand those who got the answer. Yes. I think in the marking scheme I have given you. Yes. Shamrit, as you said, in the question number 20, I think in the marking scheme, students, I have given you first one as the answer. So the answer should be second one. Okay, right. Yes, I can see that one. Now you can increase 1 mark. 1 mark, maybe 2 marks. Okay, you can increase your marks by 2. Are you all happy now? So correct that one. Question number 20 answer should be second one. If I have put wrong, you can increase marks again. Should increase 2 marks. Okay. Right. Now let's move to the question number 21. Which of the following correctly represent the variation of ionic radii? Students, they have given magnesium 2 plus, sodium plus, N3 minus, O2 minus, and F minus. So what is the specialty of these 5 species they have given? So the electrons are 10. So there are 10 electrons in each. How many protons are there? In magnesium 12, sodium 11, nitrogen 7, oxygen 8, chlorine 9 in this way. So remember isoelectronic series, so the number of protons are changed. So with the increment of number of protons, the radius is decreased. Then magnesium 2 plus should have the least radius. Then sodium plus, F minus, O2 minus, and N3 minus should have the largest radius. So therefore, question number 20, that is question number 22. Question number 22 answer is number 5. Now let's move to the question number 21. Question number 21 is also easy. Correct regarding both calcium 2 plus and zinc 2 plus ions. Same nuclear charge. When you consider nuclear charge here, calcium is 20, zinc is 30. Plus 20 and plus 30. Equal number of protons. Wrong. 20, 30. Same number of electrons are in the outermost energy levels. Electrons in outermost energy level. Calcium, we can consider that configuration is Argon's configuration, no? So therefore, 3s2, 3p6. So therefore, we can say 8 electrons. And what about zinc? Zinc means 3d10. So therefore, 3s2, 3p6, 3d10. So there are 18 electrons in the outermost energy level. So therefore, that is also wrong. Number of unpaired electrons in the outermost shells. No unpaired electrons, right? 0 unpaired electrons in both, right? Number of unpaired electrons in both 0. So therefore, that should be the answer. But let's go for the next answer also. Has noble gas electronic configuration. Remember, students, calcium 2 plus has noble gas configuration. That is Argon's configuration. But zinc 2 plus doesn't have noble gas configuration, right? It's not a noble gas configuration. Then question number 21 answer should be both one. That's very easy, okay? Right, okay. Are we done? Now let's move to the question number 23. X and Y are two consecutive elements in the periodic table. X is a noble gas. Select the response which contains respective graphs given below. Right. Okay, X and Y are two consecutive elements in the periodic table, and they have given X is a noble gas. That means, students, Y should be group number 1. That means we have to go for the next period. Okay, so that means these two elements are in two different periods, no? So they have given one property is changing like this, X and Y. And another property is there, it is changing like this. X has the largest one and Y has the lowest one. And there is another property like this. Okay. So this is X and this is Y. Look at this, Anil. So what are the properties here we can consider? Atomic radius, first ionization energy, and the electronegativity. So students, X is a noble gas. That's a noble gas. Group number 18. Right? Group 18. Then Y is group number 1. Okay. So therefore, we have to go for the next period. Atomic radius is increasing. Right? Atomic radius is increasing. Then the next one, first ionization energy. X noble gas. Always noble gases are having first ionization energy always high. Right? Helium, neon, argon. And therefore, this graph is representing the first ionization energy. No? First ionization energy. Because you can see that in the graph also, helium, then only lithium comes. Neon, sodium. Argon, potassium. Likewise. See? So then we can consider here X and Y. X is a noble gas. Y is group number 1. This is the variation for the first ionization. Then what about the first graph and the second graph, as you think? The first graph and the second graph are representing. So they are increasing, okay? X, Y. We have electronegativity and the atomic radius. Atomic radius, I told you, increasing. X has the lowest atomic radius. Y has the largest. Because X is a noble gas, Y is group number 1 means we have to go for the next period. Then one energy level is increasing. And this is also increasing and this is also increasing. What should we take? Now look at this one. Here, they have given a property that we are considering for X is 0. The property that we are considering for X is 0 here. Then what is that property, as you think? Is that atomic radius? No, electronegativity. Can you remember we didn't discuss about the electronegativity of the noble gases because they are not making chemical bonds. Then this is electronegativity. Because X is a noble gas. This is electronegativity. Then what about this one? So this is atomic radius. Atomic radius, first ionization energy, electronegativity. So these three variations given in the answer number 1. Question number 23, answer is number 1. Okay, question number 23, answer is number 1. Raise your hand those who got the answer correctly. Okay, very good. Yes, what are the doubts you have? How do we tell that Y is group number 1? Now, they have given X is a noble gas. No? Noble gas means group number 18. And they have given at the question X and Y are two consecutive elements. That means one after the other. Then Y should be Group number 1. Just imagine neon, sodium, right? Helium, lithium, neon, sodium, potassium, argon, potassium, likewise. Understood? Read the question carefully. Huh? Right. Right. So let's move to the question number 24. The first and the second ionization energies of two elements are shown in the graph below. By considering the graph, find the group to which capital A and capital B belongs to. Students, they have given the graph. This is very easy. Okay. If you can remember the ionization energy graph, then you can easily answer for this one. Look at this, Anilu. Ionization energy and the element. So they have given two variations like this. So this is first ionization energy and this is the second ionization energy. Okay. If the ionization energy, second ionization energy suddenly changes in this way, what should be A and B? Belongs to which groups? Just think about this. That means when we consider first ionization energy is highest in capital B. Second ionization energy highest in capital A. Right? And what kind of variation is this? So let's go one by one. 17 and 80. Group 17 and group 80. A and B. Yes, first ionization energy variation is like this. Right? If I consider 17 and 18, okay. Then second ionization energy. Second ionization energy of group number 17 and 18. Just imagine this is fluorine and neon. This is the second ionization energy, no? This is the first one. First one. Then first ionization energy of fluorine and neon, group number 17 and 18 is like this. But here they have dropped. So therefore, we can't take the first answer. Then go for the group number 16 and 17. Just take oxygen and fluorine. Oxygen, fluorine. You know that nitrogen, oxygen, fluorine. I mean, like this. So that is increment. But here they have given decrement. No? So this is a decrement. I'm talking about first ionization energy. Remember the graph that we learned, right? Oxygen, chlorine, increment. But here, decrement, can't take. Group number 1 and group number 2. Let me consider lithium and beryllium. So there also you can see increment in the first ionization energy, right? First ionization energy is in the increment. Then we can't take here decrement. What about the fourth one? Group number 18 and group number 1, right? Let me consider neon and sodium. Then we have a sudden drop. Neon, sodium. Then it is applicable, no? What about the second ionization energy? In the second ionization energy, what will happen? Right? What will happen to the second ionization energy? Second ionization energy, sodium comes here. So neon go there. That means it is changing like this. Right? First ionization energy, and this is the second ionization energy. Neon comes here, sodium goes there. Second ionization energy highest in sodium because it is belong to group number 1. Okay, so just remember the ionization energy graph that we learned, first one and the second one. When we draw the second ionization energy graph, what we are going to do? We are going to drag the elements one by one to the backward direction. Okay, so the place where that we have sodium, now sodium is going for the neon's portion. Neon is going for the chlorine's portion. Likewise. No? Then this is the variation. So the answer should be group number 18 and group number 1. Anyway, let me check 14 and 15 also. So 14 means we can take carbon and nitrogen. Right? So carbon, nitrogen also increment. So first ionization energy. So students, you don't have to look at even the second ionization energy. When you analyze the first ionization energies of these, the variation of the groups, right? Then you can see always increment here. But here they have given decrement in the first ionization energy. That decrement is taking place between group number 18 and group number 1. So therefore, easily you can go for the answers. But you have to be very tricky. Okay. Question number 24, answer should be fourth one. Raise your hand those who got the answer. Yeah. Question number 25. Select the element shows a positive electron gain energy. Remember, when we discuss about the electron gain energy, I told you there are 3 elements can have positive electron gain energy values: beryllium, magnesium, and nitrogen. Beryllium, magnesium, and nitrogen. Okay. So they have given chlorine, sodium, nitrogen, fluorine, aluminium. Third one, question number 25, answer is third one, nitrogen. Yes, I'll explain that one again. Right, okay. Let me explain the question number 24. Again, listen to this one. Students, they are asking the first and the second ionization energies of the two elements are shown in the graph below. So these are the group numbers. First ionization energy of group number, we don't know exactly which group, A and B, consecutive elements. So varying in this way. Second ionization energy in this way. That means first ionization energy of A is greater than B. Second ionization energy of B is greater than D. They are asking these two elements are belongs to which group? They have given 5 answers. I'll go one by one. Group number 17 and group number 18. That means A belongs to group number 17, B belongs to group number 18. So let me take group number 17 element is fluorine, neon. Okay. 25th one. Okay. So 25th one is easy, no? That is completely theory. Select the element shows a positive electron gain energy. So these are the only 3 elements which are having positive electron gain energy because of the stable electronic configuration. Understood? Beryllium, magnesium are having S2 configurations. Nitrogen-like elements are having S2P3. So specifically beryllium, magnesium, nitrogen, these 3 are having positive electron gain energies. Nothing to explain there, right? So why they have positive electronic configuration? The reason is stability of the configuration. Beryllium, magnesium S2 configurations, nitrogen S2P3. Understood? So therefore, question number 25 answer is third. Okay, then I don't have to explain the 24th one, right? Shall we move to the 26th one directly? Does anyone need explanation for 24 again? Yes. Then let's move to the 26. Which is not true regarding the modern periodic table. Majority of the elements present in the periodic table are metals. I told you 80% of the elements are in the periodic table are metals. So therefore, they have given a majority of the elements present in the periodic table are metals. That is a true state. But in this question, they are asking not true statement. Not true. You have to be very careful these kind of questions. Among the elements of the P block, there exist the elements belong to 3 states of solid, liquid and gases. Yes. In the group number 17, can you remember? What are the group number 17 elements? Chlorine, chlorine, bromine, iodine, astatine. Remember fluorine, chlorine, they are gases. Bromine is a liquid. Iodine and astatine both are solids. Right? Halogens, yes. So halogen group is containing all 3 states of matter. Among the elements of the P block, there exist the elements that belong to, yes, that is correct. The modern periodic table is prepared based on the atomic number. Yes, atomic number is one of the factors. And the other factor, electronic configuration. Number 4, nuclei of all the elements of the periodic table have protons and neutrons. No. Hydrogen doesn't contain neutrons. Right? Hydrogen has only 1 proton, 1 electron. That statement is wrong. Within first 4 periods of the periodic table, there are 11 elements which exist in gaseous state of the room temperature. Yeah, 11 elements are there. What are they? 11 gases are there. So they actually exist in the first 4 periods. What are the 11 gases? Hydrogen. Then we have helium. Right? In the second period, we have nitrogen, oxygen, chlorine, neon. In the third period, we have chlorine, argon, then krypton, xenon, radon. Period number 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 gases. in the first 6 periods. So the fifth statement is also correct. They're asking the not true one. Question number 26, answer is fourth one. Let's move to the question number 27. The variation of the atomic radius, first ionization energy, and electronegativity across a period, left to right, down a group of the periodic table is correctly given by, right? Students, the first property that they have given is atomic radius, right? So what is the theory? Along a period, the atomic radius is decreasing, right? Atomic radius. Okay, first of all, down the group. Then along the period. Okay. So what will happen to the atomic radius down the group? Increasing. Down the group, it is increasing. What will happen to the along a period? Decreasing. Right? So therefore, the first one is wrong. The first option they have given is wrong. First ionization energy. Plus down the group, first ionization energy is decreasing. Along a period, I told you that neither increasing nor decreasing. It's a zigzag variation. We can't exactly tell that one. It is an increasing pattern, but it's not proper increment. Zigzag variation. Understood? Then the next one, electronegativity. What will happen to the electronegativity? Electronegativity is down the group. What will happen? Down the group decreasing. Right? Along a period, increasing. Along a period, electronegativity is increasing. Then they have given what are the other factors? Yeah, that's all. Atomic radius, first ionization energy, electronegativity. Then second option that they have given is also wrong. Third one, both are increasing, wrong. Fourth one, atomic radius increasing down the group, across the period left to right decreasing. That's correct. Question number 27, answer should be fourth one. What about the last one? Down the group decreasing ionization energy. And they have given across a period left to right normally increase. I told you we can't say like that. It's a zigzag variation, right? That means increment also there, decrement is also there in some other. So therefore, we can't exactly tell that. So question number 27, answer should be fourth one. Right? Raise your hand those who got the answer. So some interesting graphs also there. Ne? Question number 24. Question number 23. The tables are given 27, 28. So the paper is very interesting paper. Right. Okay. So let's quickly move to the question number 28 also. Right, okay. Can you hear me, students? Can you all hear me? Right. So just analyze the table that they have given. When you look at the table that they have given, I told you when you are given these kind of ionization data values, check where you can see the largest energy gap between the consecutive ionization energies. Especially when you analyze BCD, right? Elements BCD, look at this only. Between 490 and 4560, there is a large gap. Between 736 and 1000, no. Between 1450 and 7750, there is a large gap. And again, between these two, see, a large gap is there. Then you have to understand for this capital B element, second ionization energy is very large. Okay. Second ionization energy is large. Right. You just compare the ABCD elements. When you consider ABCD elements, the largest second ionization energy belongs to B. When you compare ABCD elements, the largest third ionization energy belongs to C. And here you can see largest fourth ionization energy belongs to D. Among these, largest first ionization energy belongs to A. Students, can't you guess the elements? You just go for the graph that you learn. In which element the first ionization energy is largest? In which kind of elements? Hydrogen, helium, group number 18, neon, argon. So therefore, these are group number 18, right? Capital A belongs to group number 18, right? Can you remember second ionization energy larger in which elements? Group number 1 elements. Group number 1, right? Third ionization energy largest in which group elements? Second one. Fourth one is belongs to group number 30, right? So analyzing these patterns can easily go for the answers. Understood? And you look at the table that I gave you. Students, this is neon, sodium, magnesium, aluminum. Exactly, right? The table that I gave you, that is about 2080 again, but this is 2100, right? So this is neon, sodium, magnesium, aluminum. Very easy, right? So when you compare these values, first of all, check whether where we can get the largest values, largest energy gaps. And then when you comparing these four elements, that large value is belongs to that four elements. When you compare the other elements also, that is the largest value. Then you can decide the group now. Group number 18, group number 1, group number 2, and group number 13, consecutive elements. So therefore, answer is second one. Question number 28, answer is second one. Raise your hand, those who got the answer correctly. Right. Right, okay, now let's move to the question number 29. The processes shown by the following reactions are mentioned correctly in capital A. X gas is producing X plus gas by releasing one electron. B. Y gas taking up electron and producing Y minus gas. C. Z minus gas producing Z gas and releasing one electron. So you know that this is what exactly first ionization energy. First ionization, right? Electron is removed. What about this one? Electron gain energy. So this is electron gain. What do you think about this one? Z minus gas producing C gas and releasing one electron. So when you take the reverse of this reaction, just take the reverse of this one. Z gas taking up one electron and producing Z minus gas. Then this is what? Electron gain energy. Reverse of that one is electron affinity. So this is the electron affinity. Electron affinity. Then capital A process is first ionization energy. B is electron gain energy and C is electron affinity. Question number 29 answer should be second. Raise your hand those who got the answer correctly. I think we have discussed this one in the memory booster paper, if I'm correct. Uh, for you all, yes, I will put a seminar for you also. So that is for physical students. The reason is uh, I thought of to give some basic knowledge, that means your O-level knowledge for those students. For the online students also, I'll tell you when is your seminar. It's conducted seminar. Okay, nothing to worry. Portrays something fishy. What do you mean by that? Your smile portrays something fishy. Explain it. Yes, my plan is to discuss all the questions today. Is it hard to stay? Right, okay. Question number 30. The atomic number of selenium is 34. The correct orbital diagram of electrons which are present in the valence shell. So look at this one, selenium. So selenium is 34. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, so 10, 20, 30, 4p4. So therefore the orbital diagram should be 4s2. There are 2 electrons. In the p sub energy level, we know that 1, 2, 3, 4. Okay. So this orbital diagram that they have given is in the last one, number 5. Question number 30 answer is number 1. Right? Okay. Raise your hand those who got the answer. Question number 31. Yes, question number 31 to 40. We know that ABCD statements. So let's quickly discuss this. Which of the following can show the tendency to form diatomic molecule? Students, chlorine is already producing, right? Chlorine is actually producing diatomic molecule, Cl2. But remember, magnesium can't produce diatomic molecule. The reason is magnesium's valence configuration is S2. So therefore, it cannot produce diatomic molecule. Understood? Then the next one, neon. Neon is not forming diatomic molecule anyhow, because neon is a noble gas. What about sodium? I told you under the theories. Sodium is producing sodium diatomic molecule under special conditions above 400 degrees Celsius, right? Above 400 degrees Celsius, sodium can produce diatomic molecule. Anyhow, it can produce, right? Magnesium can't produce because of this too stable configuration. Neon is a noble gas. It's very, very stable. So therefore, chlorine and sodium can form diatomic molecules. Question number 31, answer should be fourth one. A and B statements are correct. So therefore, answer is fourth one. Raise your hand those who got the answer. Right. Question number 32. First 7 ionization energies of an element X are given. X are as follows, right? 1310, 3380, 5310, 7460, 11,000, 13,300, 84,760. I1, I2, I3, I4, I5, I6, I7. Let's see what are the statements. It belongs to the group number 60. How do you find out that? Students, I told you, when you are given these kind of consecutive ionization energies, always what you have to do, you have to analyze the largest energy gap. Look at these two values. These are the two values representing the largest gap, right? So the gap is actually about 84,760 minus 33,300, 0641, 71,460, right? Then you have to understand that this is the separation of the principal energy levels, right? That means 1, 2, 3, 4, 5, 6. 6 electrons are belong to the valence principal energy level. If there are 6 electrons in the valence principal energy level, tell me, students, that element belongs to? If there are 6 electrons in the valence principal energy level, that element belongs to group number, what is it? 60. Simple, right? S1, S2, S2P1, S2P2, S2P3, S2P4, S2P5, S2P6. In the valence shell, only 1 electron is there, group number 1. 2 electrons are there, group number 2. 3 electrons are there, group number 30. 4 electrons are there, group number 40. 5 electrons are there, group number 15. 6 electrons are there, group number 60. 7, 17, 8. See? So therefore, the statement that they have given is correct. It belongs to the group number 60. If you want, you can further confirm that one. Proof number 16, S2P4 configuration is there. No? Look at the separation of the sub-energy levels. That means the next largest, slightly large energy gap is between these two. 0, 4, 5. This is 3,540. So this is the slightly large energy gap. And here we can see that this is about 2000 something, right? Yes. And here also we can say that 1930. And here the gap is 2000. So therefore this is 2000 range. And this is suddenly increasing 3540. So therefore we can say that these 4 electrons are belong to the P sub-energy level, P4. And these 2 electrons are belong to the S sub-energy level, S2P4, group number 16. The minimum valence is 2. Yes, group number 16 means in the second unit I told you that cyan, sulfur, selenium, tellurium, polonium. The common valencies are 2 and 6. Okay, so the main valence is 2. It can easily form X6 plus ions. Wrong. Have you seen that oxygen is producing O6 plus? Right. It can only form anions but cannot form covalent bonds. Oh, that's wrong. Right. Remember, so even though they are producing anions, now tellurium, polonium elements can form cations also, because down the group metallic properties are increasing. Okay, oxygen, sulfur, selenium, they are forming anions. That's okay. But tellurium, polonium, they can form cations because they are metals, and but cannot form covalent bonds. Can't they form covalent bonds? Wrong. So A, B statements are correct in the question number 32. A, B statements are correct. C and D statements are wrong. Question number 32 answer is first one. Raise your hand those who got the answer. Right. Right, okay. Let's move to the question number 33. The correct statement regarding the emission spectrum of hydrogen is it occurs when electrons are excited to higher energy levels from low energy levels. Is that correct? No, right? So, so electron transitions are towards the lower energy level from higher energy level. So therefore, simple A statement is wrong. We can't accept that. So they have given the opposite. The energy transitions when electrons fall from the fourth principal energy level to the third, and when the electrons fall from the third energy level to the second energy level are equal. No, that's wrong. Look at this only. How they can be equal. So they have given that electron transitions fall from the fourth energy level to the third one, equal to the third energy level to the second one. So are they equal? Look at the gaps value. They are not equal, right? So therefore, simple B statement is also wrong. C, the frequency difference between H alpha and H beta lines. So where is H alpha, H beta? Let me draw the Lyman series. Students, even here after this, we have discussed so many questions from hydrogen emission spectrum. If you are still making mistakes in the hydrogen emission spectrum, means it's your fault, okay? See how many questions we have done. Now in the paper class also we are discussing past exam questions. H alpha, H beta, H gamma and H delta in this way. The frequency difference between H alpha and H beta lines is equal to the frequency difference between the second and the third lines found in the Lyman series. So where is the second and third? Let's see the gap. Second line, this one, electron transition. So this energy gap, no. H alpha, H beta. This energy gap. Yes, that's correct. What you have to do is, you just consider the electron transition diagram, H alpha and H beta, the energy gap is 3 to 4. And here, second line and the third line in the Lyman series, that gap is also 3 to 4. So therefore, the frequency difference is same. That's correct. C statement is correct. D, the gap between Lyman and Balmer series is higher than the gap between Paschen and Balmer series. Right? The gap between Lyman and Balmer is higher than the gap between Balmer and Paschen. Remember, students, when you consider the other series, actually, they are getting closer towards the previous series. Okay? Because the gaps are decreasing, no, energy gaps are decreasing, no. So therefore, they are getting closer. So therefore, the statement that they have given is correct. C and D statements are correct. Question number 33, answer is third one. Question number 34. The correct statement about cathode rays is its E of M ratio value differs from one gas to another. Wrong, right? That's wrong. E of M ratio value is a constant. B, it's emitted perpendicular to the surface of the emission. Yes, correct. Since it create a momentum, it has a mass. Correct. Electrons is an element identical to cathode rays. Correct. BCD, Question number 34, answer is number 5. Question number 35. The last electron filled to a certain atom, according to the Aufbau principle, has a quantum number n equal 3 and L equal 2. So the last electron filled to a certain atom, according to the Aufbau principle, has quantum number n equal 3, that means third principal energy level, L equal 2. Students, L equal 2 means angular momentum quantum number is 2. If n equal 3, that is third principal energy level, L equal 2 means D sub energy level. So therefore, they are talking about 3D energy level. Which of the following statements are true regarding that electron? The electron is in d orbital. Yes, correct. B, the spin quantum number of that electron should be ms equal plus half. We can't say should be. It can be plus half. It can be plus half, it can be minus half. The term should be is wrong. So therefore, B statement is wrong. C, that electron can be removed when first ionization energy relevant to that atom is supplied. That electron can be removed when first ionization energy relevant to that atom is supplied. We have to understand this one very carefully. According to the Aufbau principle, the way that electrons are filling in this order, can you remember? Right. One S, 2S, 2P, 3S, 3P, 4S, and 3D. Students, now the way that electrons are filling is 4S and 3D, according to the Aufbau principle. Now they have given that the electrons are filled to 3D. Then you have to understand that electrons are already filled to 4S. Right, okay? So students, according to the Aufbau principle, here electrons are filled to 3D, no? Then already 4S is filled. Already 4 is filled before 3D. You have to understand that. Then when you write down the configuration, this is the filling mode. This is the filling mode, right? Then what is the configuration? What is the electronic configuration? Electronic configuration is 1s, 2s, 2p, 3s, 3p, 3d, and 4s. Then if you are giving the energy to remove the electrons, you are removing electrons from the valence shell, right? What is the valence shell? 4s. Then the first ionization energy supplied means electrons are removed from the 4s, not from the 3d. Because 4s is the outermost one. Understood? Can you understand what I'm saying? Right? Even though electron filling order is like this, right? Already 4s electrons are there. So when you arrange them in the order, correct order, this is the order. So when you give energy to remove electrons, just imagine you are giving an energy to remove the first electron, that is first ionization energy. Then you are removing electron from 3DO 4s. You are removing electron from 3DO 4s. Just try to understand that. From where? We are removing electron from 4s. Understood? We are removing electron from 4s. Then look at this statement. That electron can be removed when first ionization energy relevant to that atom is supplied. Wrong. If you supply energy that is relevant to the first ionization energy, you are not removing 3D, you are removing 4s. Therefore, C statement is wrong. Raise your hand those who understood that explanation. Do you have any doubts there? If you have any doubts, put doubts. That electron exists in the third principal energy level. Yeah, that's okay. That's correct. A and D statements correct. Question number 35 answer is 4. (36) Which of the following statement are true regarding quantum numbers? The maximum number of electrons in an energy level is given by n square. No. That is given by 2n square. Can you remember? 2n square, n equal 1. So therefore 2 into 1 square, 2. N equal 2, 2 into 2 squared is 8. N equal 3, 2 into 3 squared. N equal 4, 2 into 4 squared, 32. So it's not n square. Wrong. B statement, the number of electrons may present in a principal energy level is always equal to 2n squared. Is that correct? Remember, students, these are the maximum number of electrons that can occupy. But it doesn't mean that always there should be these electrons. Right? Now, when you consider the elements, are they always completely filled with electrons? No. So therefore, the number of electrons may present in a principal energy level is always equal to 2n squared is wrong. That statement is wrong. Not always. These are the maximum that can exist. Right? C. The maximum number of electrons present in a principal energy level is given by 2n squared. Now that's correct. Maximum number of. The number of orbitals present in the energy level is equal to n squared. That is also correct. Now, you just consider n1. So n squared means 1 squared. That means 1. In the first principal energy level, we have only 1 orbital. Let's go for the second one. 2 squared. That means 4. Why it is 4? We have s orbital, and the p sub energy level, there are 3 orbitals. Then 1 and 3, 4. Just consider third principal energy level, 3 squared. There are 9 orbitals. How? 1 s orbital, 3 p orbitals, and 5 d orbitals. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? When you add the f sub energy level, 60. Number of orbitals are given by n squared. That's correct. Right? Then C and D statements correct. 36 answer is number 3. Akira specially focus on unit number 1, high region emission spectrum, electronic configuration, quantum numbers, then atomic radius, those things you have to focus more. Those are the parts that you can expect the questions mostly. Understood? Question number 37. Which of the following ion has have electronic configuration of a noble gas? Chromium 3 plus. Chromium's electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. So Cr3 plus means 3d3. So this is not a noble gas configuration, right? Wrong. Copper 2 plus 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1, 3d9. So therefore, configuration C. Canadium 3 plus 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. So therefore, this is actually equal to the argon's configuration. So this is argon's configuration. Gallium 3 plus. Gallium is 33. 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p3. So gallium 3 plus means these 3 electrons are removed. This is zinc configuration. It's a noble gas. It's not a noble gas. Only C correct. So therefore, question number 37 answer is number. Question number 37 answer is number. Right. Now let's move to the question number 38. So that is also related to the hydrogen emission spectrum. Let's see. In this way, a diagram is given. Simple A. Wavelength of the energy released in the transition A is corresponding to the Lyman series. Is that statement correct? Wavelength of the energy released in the transition of A is corresponding to Lyman series. Yes, that is wrong. Why it is wrong? Students, they have given energy released, but that is an absorption. No? The electron is actually going from low energy level to high energy, right? According to this diagram. That's why that statement is wrong. Otherwise, if they have given wavelength of the energy absorbed in transition capital A belong to Lyman series, then okay. And one more thing we are discussing about emission spectrums, right? Lyman, Balmer, Paschen, everything in the emission spectrum. So this is absorption. Simple A statement is wrong. B. An emission spectrum at transition capital A and the absorption spectrum at transition B. Students, this is absorption and this is emission, right? You can see that one. B statement wrong. Wavelength of the energy released in the transition B corresponding to the Lyman series 2 to 1. So therefore Lyman series release energy. D. Wavelength of the energy released. Students, again, in the transition C, energy released or energy absorbed? What is it? It is energy absorbed because electron is moving from low energy level to high energy level. So therefore, here they have given wavelength of the energy released in the transition C corresponding to the first energy. It should be corrected as energy absorbed. So therefore, that is wrong. A, B, D statements are wrong. C statement is correct. 38 answer is number 1. Raise your hand those who got the answer correctly. Good. Question number 39. Which of the following statements is true regarding properties of atoms? Covalent radius of carbon atom is less than Van der Waals radius. Students, can you remember in the unit number 1 we learned covalent radius is lesser than the exact radius. Exact radius is equal to the metallic radius. Exact radius is lesser than Van der Waals radius. Right? So therefore, covalent radius of carbon atom is lesser than Van der Waals radius. That's correct. According to the Pauling scale, electronegativity of sodium atom is less than electronegativity of aluminium. Along a period, electronegativity is increasing. So therefore, definitely, sodium should have low electronegativity than aluminium. Right? B statement is correct. Right? Ionization energy of an atom is determined only by its nuclear charge. Wrong. Remember, students, its electronic configuration is also affecting. Right? Electronic configuration. Okay. Then other factors also, their shielding effect, atomic radius. So nuclear charge is also affecting factor. So they have given ionization energy of an atom is determined only by its nuclear charge. Wrong. Right? Electronic configuration is also one of the factors. Right? Second ionization energy is maximum for the element in group 2. No. Second ionization is highest in group number 1. A and B statements correct. Question number 39, answer is number 1. Question number 40 is also easy. Of the following scientists who contributed in creating the periodic table? So, Lothar Meyer and the Mendeleev. So, answer is number 1. Up to question number 40. Right. Akira, are you a poet? At least give an interval, sir. Only few minutes. Few minutes. Last 10 MCQs. Right? In the last 10, actually, discussion is very simple. Okay. Right. Let's finish the paper. Okay. Question number 41. Very good. That's the spirit. 41. In a magnetic field, the accelerated electrons move towards the north pole, while in an electric field, they move towards the positive terminal. Students, in the electric field, that they are moving to the positive terminal. In a magnetic field, perpendicular direction. So therefore, the first statement is wrong. Second one, since accelerated electrons have a negative charge, they behave in the same way as negative particles. Correct. First one wrong, second one is correct. Answer is number 42. The van der Waals radius of an element is smaller than its covalent radius. Just now we learned van der Waals radius is always greater than covalent radius. So therefore the first statement is wrong. The covalent radius of an element is half of the internuclear distance at any instance. No, not at any instance. When they make chemical covalent bonds only, half of the distance. So therefore the second statement also wrong. Both the statements are wrong. 42 is number 5. (43) First ionization energy of aluminium is higher than that of sodium. Is that correct? Yes, that statement is correct, no? Electronegativity of aluminium is higher than sodium. That is also correct. Is there any connection between these two statements? Ionization energy and the electronegativity? No, right? So both the statements are correct, but no connection. Therefore, answer is number 44. 3D5 4s1 configuration is more stable than 3D4 4s2 configuration. Yes. Remember, students, 3D5 4s1 means half stable. So therefore, that's correct. The atomic orbitals are completely filled when possessing 3D5 4s1. They are not completely filled. They are half filled. They are not completely filled. They are half filled. First one is correct. Second one is wrong. So therefore, MCQ number 45. Electronegativity of sulfur is higher than that of nitrogen. Sulfur's electronegativity is 2.5. Nitrogen is 3.0. So therefore, first statement is wrong. Ability of an atom to pull bonding electrons toward it is the electronegativity. Correct. First one is wrong. Second one is correct. Answer is number 46. Nucleides are atomic species with definite number of protons and definite number of electrons. Remember, students, nucleides means definite number of protons and definite number of neutrons. That's wrong. Though protium, deuterium, and tritium are isotopes of the same element, those are not nucleides. They are nucleides, right? Isotopes, nucleides, they are almost similar, right? Because definite number of protons and neutrons are there. So both the statements are wrong. Answer is number 47. I think we didn't discuss 46. Mass of neutron is greater than mass of electron. Remember, students, mass of neutron (1.675 10 to the power minus 27 kilograms). Electron mass 9.107 31 kilograms. So this is very large. That's correct. Cathode rays have properties, wave property as well as particle property, duality nature. Both the statements are correct, but clearly not explained. 48. Two electrons in a certain atom do not possess identical set of quantum numbers. Yes, that's correct. That is what we consider as Pauli's exclusion principle. Electrons spinning in same direction do not exist in an atom. Remember, electrons spinning in the same direction do not exist in an orbital, because in an orbital there are two different directions, but inside the atom there are electrons with the same direction. Right now, here when you consider d orbitals, they are in the same direction. So that term is very important. Electrons spinning in same direction do not exist in an atom. Wrong. There are. If they have given do not exist in an orbital, then correct. Right? Second statement is wrong. First one is correct. Answer is number 3. 49. The gap between two consecutive lines in emission spectrum of hydrogen gets decreased rapidly when frequency of the spectral lines decreases. Yeah, for this direction, right? We know that for this direction, approaching to each other, so energy and the frequency is increasing for this. That's correct. The distance between the energy levels decreases with the increase of the distance from the nucleus. Yeah, that is the reason why we have this kind of spectral line diagram. Otherwise, if they are equal energies, if the gap between the energy levels are not same, if they are same, then we don't obtain this kind of a, right? Second one is clearly explaining the first one. Both the statements are correct. Answer is number 1. Number 50, last one. The order of electronegativity of elements boron, carbon, nitrogen oxide, fluorine. That's correct. Same period. So therefore, this is the order. Electronegativity depends on the total number of electrons present in the atom. No. Electronegativity is depending on 4 factors: hybridization, formal charge, oxidation state, nature of the surrounding atoms. First statement is correct. Third one is wrong. Number 3. Done. Right. So this is the discussion of the test paper. So you can now count your marks if there are any errors or anything. Any doubts, students? Anything? Raise your hand those who understood the things that we discussed in this paper discussion. All clear? Right. Okay, then I'll put the recording to the WhatsApp group, so you can watch the recording also. Let's meet on the next class then. Until then, bye bye, have fun. Good evening, all of you. God bless you.